everyone, today we're gonna solve the lead code problem 76, minimum window substring. So the description is this: given two strings S and T of length M and N respectively, return the minimum window substring of S such that every character in T, including duplicates, is included in the window. If there is no such substring, return the empty string. The text cases will be generated such that the answer is unique. So we want to find the minimum window substring of S, and it requires to include all the characters of need. So our first sort and is that maybe we can use two for loop, and for the S we gonna find the substring from I to G. Therefore, the time complexity will be big O of n squared, which is really large. So we wanted to decrease the time complexity. So the keyword here is a window. So for the string, we're gonna use the sliding window technique. Step is like here. So we first we use the left and right pointer technique in the string S, and when initialize left and right is equal to 0, so we refer to the closed left and open right internal as a window. So initially we continuously increase the right pointer to expand the window until the substring within the window meets the requirements, which is contains all the character from the T. So at this point, we stop increasing the right pointer, and instead, we continuously increase the left pointer to shrink the window, and until the substring within the window no longer meets the requirements. So in that case, it no longer contains all the characters from T. So each time we increase the left pointer, we update the results. So we will repeat step 2 and step 3 until the right pointer reaches the end of the string. So this approach is not difficult. So basically step 2 is about finding a feasible solution, and step 3 optimizing the feasible solution to ultimately find the best solution, so which is the shortest current substring. And the left and right pointers moved forward alternately, so the window size increases and decreases, and the window continuously slides to the right. So this is where the name sliding window originated. So that's our result, and let's check the code. First, we need to new two hash map. One is called need and one is a window, and we're gonna put all the character in the T to the need. We will get all the character and its number, and we will initialize the left pointer and the right pointer both equal to 0, and currently the value is equal to 0 because it's about the window. So we will start and use start and length to record the result. So we enter the while loop, and we continuously move the right pointer, and if need it contains key, we will put it into the window, and the value is increasing, and there is also a for loop that we are shrinking the window. So this is our solution, and at the end we will make a judgment to see if the length is equal to the initial value or not. If not, we will return the result. So one thing we need to notice here is So in Java, when comparing objects like integer and string, we should not use the double equals operator for equal to comparison. So instead, we will use the equals method to determine if the objects are equal. So the reason is because two doubles operator checks for reference equality. So means it compares whether two objects refer to the same memory location. It checks if the two reference point to the exact same object in memory. And equals is a method that can be overwritten by classes to define their own notion of equality. So for many classes in Java, the equals method is implemented to compare the contents of value of the objects rather than their memory reference. So basically in Java, the integer is an object wrapper class for the int primitive type. So when we create two integer objects with the same value, they may not necessarily be the same object in the memory. And the string is a class that represents a sequence of the characters, and the strings are immutable. And when we create the two string objects with the same contents, they really won't be the same objects in memory. And therefore, to compare integer objects or string objects for the content or value, we should use the equals method instead of the two double operator. For the time complexity for this problem, although the code has two while loop, one nested within the other, the time complexity is not big of as squared because the inner while loop is not executed for every character in the outer loop, and the inner while loop is primarily controlled by the valid variable and the need for the window to cover all characters in T. So the time complexity is big of S for this problem. And the space complexity is big of T, and the T is the length of the string T.